So you have synthesis in your syllabus, synthesis of mechanisms, and it is for supposed to be 5 lectures. So I've thought of completing that. And so now let us begin our discussion. So first topic, as you saw in the syllabus, was about classification of synthesis problems. So let us first understand what is synthesis. And so far, what the discussion was mainly focused on analyzing existing mechanisms. Synthesis is we are trying to develop a new mechanism. Okay. So without consideration to the forces, if we are doing the analysis or we are doing something, so just the motion characteristics, then we call it as kinematics. Whereas if we are considering forces, then we call it as kinetics. So where analysis, we have an existing mechanism and we look at its position, velocity, and acceleration. Whereas in synthesis, we are given a motion and we have to develop a new mechanism. So just to give you a simple example, if you are supposed to develop a mechanism for crushing this can, okay, after using the can, if you want to crush it, right? So you have developed a mechanism to crush it. So you will have to first get the requirements. What is the height? What is the, other dimensions? And what is the motion needed? And where is the application of force will be? And then what is the, so all those things you will have to gather first. Then based on that, you may have to select what kind of mechanism you want to use, right? What kind of system will be useful. So that is the synthesis problem, right? What is the mechanism and what are the link dimensions that comes under synthesis? And then after you have done synthesis, you can do the analysis, that what is the, when I apply this velocity to this link, then what is the velocity or acceleration of the other links, right? So that is the analysis. And then further, now until now we are considering, up to this point we consider everything is rigid, so nothing is going to break. Whatever force I apply, nothing is going to bend, right? Completely rigid. But when we consider the design, then we are going to consider failure, right? What is we are studying in strength of materials. So using those principles of strength of materials, you will then design the parts, right? So, and in this, design of the mechanism is complete, right? So here, just to give you the idea where the synthesis fits in. So in the initial stage, after you have gathered the requirements, you will do the synthesis. So synthesis, the first thing to do would be type synthesis. Type synthesis would be what kind of components are there, what are the links or joints or gears, pulleys, belts. So not the dimensions, but what components, which components. Okay, so that is called as type synthesis. So I am going to use this. So type of mechanism, right? So all those things come in type synthesis. Whereas next is called as number synthesis. So what are the degrees of freedom? Which would be the input link? What are the number of links? What are the joints? All this comes under number synthesis. Okay. And then the last one is the dimensional synthesis. So that is the determination of dimension of links. So this module mainly focuses on dimensional synthesis. So we are going to consider dimensional synthesis for planar mechanisms. We will mainly be focusing on 4 bar, either 4R or RR PR, right? What do you understand what I'm saying, right? Either the 4-bar chain or the slider crank chain. Mainly, we will consider these two. And what we want to determine, we are going to determine the length of the links and maybe the offsets, right? Whatever the offset. So this is so the main thing you can think of is that the length of the links we are going to determine in dimensional synthesis. Okay. So we are not going to select the mechanism, right? Mechanism we will be given, right? In this problem, problem, the type of mechanism will be already known. And what we are going to do is find out the length that will cause the required motion. Okay. So what are the types of problems in dimensional synthesis? So there is motion generation, path generation, function generation. Okay. So not necessarily there is any sequence to this. These are the different types of problems that you can encounter in dimensional synthesis, right? So we want to understand the classification of the dimensional synthesis. So first type of problem is motion generation. So let us say you know that this is the motion that I want for a particular object, that I want the motion in the mechanism, from the mechanism. Okay, so usually we will think of the coupler of a 4-bar linkage. Okay, so coupler of the 4-bar linkage means the middle link of the 4-bar linkage. यहाँ पे ये जो intermediate link है, coupler it is called. It is to be guided in a prescribed manner, which means that we know intermediate locations also we know, and we would like to have that motion, and based on that I'd like to find out the dimensions of the mechanism. So everyone is clear what we are looking at? So you know about so let us say for 4-bar chain, you know the inversions, you know what is double rocker, you know what is crank rocker, what is so here we have understood the problem that we are going to solve it using 4-bar chain only, but what is the dimension of the link so that my coupler motion will be following this. So let us say you are developing a desk. Okay, जो desk use होता है. So here there are the two pivots, and you want to design the links that will cause the desk. तो desk normal position में ऐसा होना चाहिए जब तुम लिख रहे हो, और उसको तुमको फोल्ड करना है तो ऐसा करके, ऐसा घुमा के फोल्ड करके it will remain in the not opened position. It has to turn, I think, this way. So it will first go down and then turn this way, like this. So if these three locations are known, then I would design the length of the links. Similarly, let us say there is a dumper truck. So this dumper, I know the three positions of the dumper that the dumper has to take during dumping the waste, right, or whatever the material in that truck you want to dump. So the first position, second position, third position will be known, and I would like to find out what is the dimension of links that would cause this motion. Okay, so it is not um, not I mean we cannot just randomly assign some dimension that will not cause that motion, right? We will have to find out what how to get those dimensions. So that is the problem we are going to deal with. So there are two variations in the problem types, right? If I know the pivot location or I don't know the pivot location, right, in the motion generation problems. Next type of problem is called as the path generation problem. So let us say you have a prescribed path, that is a curve, a coupler curve, and so you have the points on the curve, and you would like to design the mechanism that would follow. So again, we are talking about again the middle link only, right? The coupler curve only, the coupler only, and the coupler will take the points on the coupler curve have to be achieved by properly selecting the lengths of the links. Okay, so there are also two types of problems in this. When the input link movement is not specified or the input link movement is specified. So let us say the input link movement is not known, then the problem will be somewhat different than the problem then if the input link movement is given. So this much angle it is going to take, and you have to make sure that it follows the other. So these are the two types of problems for uh, path generation. Then we have function generation. So here we have input link and output link. If you remember, we have an input link and an output link. So if the input link and output link have to maintain a functional relationship, so input link moves some degrees, then the output link correspondingly has to move to those degrees. Again, input link moves to some degrees, then again correspondingly output has to maintain. So that this is given, and accordingly we have to design the mechanism. Okay. So everyone clear about the three types of problems? This is the classification of dimensional synthesis: motion generation, path generation, function generation. So let us take up the motion generation problem. Okay. Uh, Now the examples that we saw here, you can see there are three positions. So three position synthesis is the main that mainly discussed, and a few examples of four position synthesis will be there, right, as per your syllabus. So we will not um, mainly focus. Four position will have consider specific cases of four position synthesis, and we will also consider graphical synthesis of slider crank mechanism. Okay, so mainly uh, three position synthesis of 4-bar mechanism, as well as um, we'll consider slider crank mechanism and also four position synthesis for 4-bar mechanism. So that is the scope that we are going to discuss in the syllabus. Okay, let us take the first type of problem, that is with the motion generation. It can also be called as rigid body guidance. We'll be given three positions of an object, and we have to design the mechanism accordingly. Okay. So let us see the graphical technique. We will be only discussing graphical techniques. There is also analytical techniques, but it will be out of scope for us. Okay, so let us think of this problem where I have three prescribed positions of a body. Okay, so I want to have the motion. It should have three different locations. What is the difference between point and a rigid body? Rigid body will also have a orientation. right? Point doesn't have an orientation. So point you can have just the position, whereas so here this technique involves considering any two random points on the body. Okay, so the problem will be given um, with just the body is visible, the three locations of the body visible, but you then start your synthesis. So you will have to take 2 points on the body. There is a coupler motion, so the coupler will have at least two locations where you do the joint, right? There will be joints at these two locations, let us say. So 2 points we consider, and then the same 2 points you will have to draw on the in the three orientations, whatever the three orientations. So first step would be that. Okay. So the first point, what is the motion of this first point? Okay. So the first point has to pass through these three location, these three points. Okay. So if I draw a circle passing through these 3 points, then that would be one of my pivot locations. So let me show you. So I could actually use circle through 3 points, but then the center of it doesn't become clear. So let us not do that. How you will do it in reality, right? You will do it on pen and paper. So in pen and paper, you just connect these points. Then you draw the perpendicular bisector.
डायरेक्टली इसको नहीं ले सकते क्या सरकम सेंटर को
डायरेक्टली दे सकते हैं यहाँ पे, मैं वही बोल रहा हूँ, लेकिन I need to have the center. Okay, so how do I find out? I found out the perpendicular bisector of this segment and perpendicular bisector of this segment. The intersection point becomes the center. Okay. So perpendicular bisector कैसे निकालते हैं? Engineering drawing में you have studied about it, right? You take the compass, take a distance that is more than half of this line, draw an arc here, take the compass, draw an arc from the other side, and you do this on the other side, this side also, and then you draw the perpendicular bisector, right? So perpendicular bisector, you know how to draw. So now the intersection of these two perpendicular bisectors gives me one of the pivot locations. Second pivot location I can get okay. So this is the first pivot location, this is the second pivot location. You may want to mark it with a point. If you want, so this is the procedure that we followed. So we are not given any specific locations in this particular problem for the pivot. So we were able to do it quite simply. Right. So how do I draw the mechanism? The final mechanism I can draw. So as you can see, this particular mechanism, you will be able to move it through the three locations. So you can see the first position and the second position. Clear? This is the first position. You are able to see? And it will also go to the third, but the third actually this software is not really made for mechanism uh, simulation, so you will not see it properly. But I hope the first two positions itself makes it clear, right? What is happening?
Yes.
So any doubts? No doubts, we can move to the next problem. Okay, so let us look at a problem where the same problem we can have with the positions of uh, the pivots or the ground links specified. So I have just drawn these polygons to represent the ground links. It is nothing. That is software is only for drawing geometry. So randomly let us place the pivot locations. So now I have pivot location specified. Then what I will have to choose is the points where I connect to the body. Right, those points will not be really. Now I will have to choose them. Right, so these 2 points will follow the same procedure. We will locate any 2 points on all three orientations. But now we will have to follow what is called as inversion method. Okay, so you have which link we make it fixed. Based on that, we get the inversions. So how this inversion method works, let us see. So what we are going to do is, we are going to, let us say for this pivot location, we will get the distance from each of the points. Right, we can draw these segments. So let us move this pivot location a little bit because I can see that we ourselves will be confused. Is that the problem we defined with the problem will have these two locations given and you cannot change that, okay? Okay, so what we are going to do is we are going to fix this link, coupler link. So there is a 4-bar mechanism, right? You have to visualize that there is a 4-bar mechanism right now. And there is a coupler which is having these points. So what we are going to do is we are going to fix this link. which means other links will move. Okay, so other links will move means I can use this triangle. This is the triangle which is formed in this location. So I can draw a triangle, similar triangle, and move actually the pivot point. Okay, so now the pivot point is not stationary for the inversion, and we are going to fix this link. Okay, the first link we have fixed. So what I will do is take the length of this segment, 10.19. So I will draw a circle with 10.19 as the radius. So I have drawn this circle. Then, so this is the next link, 12.78. So I will have to draw from the second point, 12.78, circle of 12.78. So the point of intersection of these two circles will be the new pivot location when, so this is going to become fixed, means correspondingly this is going to move. Okay. Let me make these all dotted, otherwise we will ourselves get confused. Let the ones that are based on inversion, we'll make them dotted. So everyone understood how I determined this point? For the second location, instead of allowing the mechanism to move to the coupler location moves like this, what we have done, we have fixed the coupler and correspondingly the point has moved. The pivot point has moved. So the second, this point corresponds to second position of the link. How about the third one? So 5.3, that is the length. I need to draw this. Right, this first point moves here. So this is corresponding to the first point. So it should be 3.78. I don't make any mistakes. Second one, oh, sorry. What is happening? Get rid of this point. 5.3 is from the second point, for the second point. So I have to draw the circle, center and radius, 5.3. Okay. So so you can see there are two locations where the intersection is happening, right? So in this particular case, we can see that if the sequence is from here to here, we should take the one on the other side. So this one we will take. So let us take this, make it again dotted. चाहिए point be selected. Okay, so what we have got is 3 points corresponding to the three pivot locations uh, of the left pivot corresponding to the three coupler curve orientations. So again, we can draw a circle with center, with a circle passing through these 3 points. So in order to find the center, we'll have to again connect the segments. And then we can draw the perpendicular bisectors. So this is the point. Let me just mark it so that we don't forget. Okay. So what is this point? This point actually is the point on the coupler curve where I should join the, so this is the first left side point on the coupler curve. Correspondingly, let us now do for the, so this is the half of the problem is over. Actually now it is 11:15, so we will not be able to complete the later half. But what is the later half of the problem? You will connect these 2 points to the second pivot and again use the same link as the fixed link and find out uh, the inversions of the uh, pivot location for the two other link locations. So accordingly, you will get 2 points. So this point plus those 2 points, so the 3 points, we will have to find out the center of the circle which passes through those 3 points, and that those two, uh, so we will have from here to this point and to the next other center that will be determined, and to the next pivot. Like this, the mechanism will be there. Okay, so that mechanism will allow this motion. So you will say that this point is not on the first link also, right? So actually the link shape will have to be modified accordingly. You understand what I'm saying? This has to fall on the link. So you can maybe make a triangle like this. Okay. The other point also will come somewhere. So we'll have to make the link shape so that that point falls on the link. Okay.